Before we continue with the video, if you like what I'm doing here on this channel, please consider subscribing. It helps the channel a lot. Anyway, let's get back to the video. This is essentially what we will be creating today. We will be creating a combo system, which is easy to expand upon. We have here, I can press my first combo ability and then it resets if I don't do anything else, or I can press it multiple times and you can see that it plays multiple parts in a combo, and you can have different animations for different types of combos. In this case, we have two different inputs, light and heavy, which dictate how the combos will turn out. And all of this is handled by creating a animation state machine, which is very easy to expand upon and gives a good overview over the different combos that are available. So we have the different this tree's different branches, which essentially shows you the different combinations. So we have a light and a light heavy, and we have a combo that just consists of a heavy, and then the logic behind it to allow it to function. So it's very easy to add more different inputs that will allow different states like medium, hits and stuff like that, and you can expand upon further with more and deeper combos, and it's very easy to just put in the proper functions to start and end a state, and then the animation that you want to play for that specific part of a combo chain. In addition to that, we also go through how you can transition between a locomotion state machine into this and out of it if you're something like that interrupts you, like damage and something like that. Welcome back. In this video, we're going to be looking at how you can create a combo system with 2D using PaperZDS plugin. So if you have followed along with my PaperZDS tutorial so far, you'll be at the exact same spot as I am here. But if you have not, no worries. I will be doing everything so that this should work for any 2D project, as long as you're using PaperZDS, though that is sort of a requirement because of what we will be doing. And regardless of what setup you have, you should probably be able to do what we do today. And in addition to that, this will be a little bit different in that not only will I go through my solution for how to create this and talking how that works and why we're doing things, we will also be starting from the beginning. We will be starting out with discussing how to come to this solution based on what requirements, what kind of specification I want for this combo system to have as functionality. So we will be starting from the beginning, going from an idea, going through some of the potential solutions, why some of them would not work, or what would be the benefits of the one that we actually end up with. So if that part is not of interest for you, you can just jump ahead to the actual part where we're creating the systems. But if that is of interest to you, then we'll get started with that right now. So let's talk about our specification. What do we want this combo system to be able to do? Well, first off, I want this combo system to start off with having light attacks and heavy attacks, and allowing a combination of these different inputs to generate different animations depending on where it is in a chain, essentially. So that's one part. If we bring out a notepad here, we can keep track of sort of what we want to do. So we want to have light attacks and we want to have heavy attacks. In addition to this, I also want to be able to expand upon this and have it so that we could add more attacks to this, or we could have more than two different inputs as of that. So we will be able to do that as well with our solution. And the reason for that is I like to have a bit of scalability available so that there is some room to grow in case you need it. Some solutions might be so determined from the start that you know exactly where the extent of it is, so then you don't need to have that kind of scalability. But for me, since I'm doing a tutorial for you, meaning that your requirements might vary a little bit from what I'm doing, I want to imply some of that scalability here. So, other than light and heavy attack, what do we want to accomplish? maintainability is the next big point. And the reason for this is that I feel like a system that you have created that is easy to maintain, meaning either expand upon it or just changed it around depending on your changed needs, makes for a much more pleasant development cycle and allows you to be flexible if things change. So we want it to be flexible, and we want to be flexible in such a way that maintenance is easy. So for example, if we have a combo chain, let's actually start with explaining this. So L will be denoted as our light attacks and H as our heavy attacks. So if we wanted to have, for example, something that was 3 light attacks after each other, each of these light attacks would represent a certain animation in the chain, but they might all be looking different from one another. If I at some point reach the conclusion that I want to change what the second animation here looks like, I want this to be easy to do. I don't want it to be like this huge hassle. So to be able to do that, we sort of need to have a good overview of the different combos that we will be creating. To expand and explain a little bit around that, let's say we have 3 different combos here. We have light, light, heavy, light, 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 and maybe heavy, light, heavy, or something like that. We have 3 different combos. What you might want to do, or one of the things that came to me early as like this might be a possible approach to this, is to have pattern recognition here. Because one of the first realizations you should probably have is that it doesn't really matter what your combo is, it will always be unique. For example, if I make a long combo that's light, light, heavy, 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 light, light, for example, then that is a unique sequence of inputs that generate this combo. And if I wanted to have a different combo, it can't be identical to this. It could be something like light, 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 heavy, heavy, light, light, but they are not identical. They share a lot of different properties or parts, subparts of them. But as a whole, they are different. And by making pattern recognition, you would essentially have to have a group of pattern, or a pattern of inputs that you would have and compare against. So let's say the player first puts in a L, and we would say that, okay, well, this matches this pattern and this pattern. Then the player does an L again, and you'll see that, okay, it matches this pattern and this pattern. Then it does an H, and we can see that it only matches this pattern, and this pattern has now been invalidated. It's no longer, we're not able to finish that specific combo. But the problem here is that even though we could go that approach, we could have a fairly large possibility of errors. For example, if we were to put an attack animation over here for the first L, which we can just call A, so that's the animation A, and the second L here would have the animation B, and the H over here would have the animation P, for example. Now, if we were to do this pattern over here and define that what these specific different animations are, we could say, well, it starts with an A, and then maybe we put a C because we didn't realize we have another combination or another combo that has very similar inputs, and for that one we're playing B. That means that if the player is putting in L, L, and H here, the second animation that gets played would vary depending on which of these 2 different patterns is found. So this appeared to me to be fairly prone to errors, and that's why I abandoned pattern as a sort of determination of which combos that were available to us. And simply because it was difficult to see or have this like good overview over which of the different parts would be fitting where, because I would most likely be doing each different input an object, a class, which would mean that finding out that, well, one is using a specific combo would be sort of hidden within that class, and it would not be easy to see all the different parts easily. And that is why this specific approach would fail the flexibility and making the easy maintenance a possibility for us. So after working on this further, if I actually go back and put this back here, what I figured was that the best way, the most easily handled way to make these inputs consistent would be to have them as different states. So you could go from this L state to this L state, and then it wouldn't matter because you couldn't make this error of putting the wrong animation here as opposed to this combo, because they would both be going the same chain. So this L state would be the same as this one, this L state would be the same as this one, and then when we get here and we go to H state or the L state here, they would essentially diverge from each other and be in separate states that were different, but they had a common path up until that point. So using states for this seemed to be a better way of coming to terms with identifying which order the different inputs would come in and make all of the different end combinations unique, just like they actually are. So we wouldn't get a conflict with different properties like animations for a specific input. The problem with this was that I started creating a states machine, and I essentially handled the different animations and such like that. The problem here was again that I reached a point where, even though it was fairly flexible and it was consistent and it was accurate when it came to the inputs, the maintenance part of this still became a problem, because again, the information about which of these different animations was playing depending on which input. So the third L here is a different animation from the first L. So that means they have to be contained in their own classes, and their own classes would sort of obscure the information inside. So now we actually get to the part where I landed on this, and that is, since PaperZD has a animation blueprint in it, which has state machines, we could actually make use of those state machines to visualize this. And that is what I decided to do. I decided to make something that's akin to a decision tree. So let's actually start looking at that so you can see what I mean. If we open up our animation blueprint, and this might be the one that you've been following along with in my other tutorial series, or it might be your own, it doesn't really matter. But essentially what you'll have is something along this anim graph here. You might have a state machine here already putting in some information in here. Now what we're going to be doing is we're going to be right-clicking and creating another state machine. This state machine we will, for clarity's sake, rename and call it combo state machine or something like that. Opening this up, we'll have our start node here. Now, what I essentially wanted to do is I wanted to have a, if we create a animation state here, a point where we went into and said like, this is our start state. From here, we can, depending on our inputs, react in different ways. So we could add another state here and another state here. And depending on our input, we would go one of these two directions. So the left one here, for example, could represent our light attack, and the right could represent our heavy attack. So this means that if the player starts out with a light attack, he'll go down this route and create combos that are available down here. If he starts out with a heavy attack, he'll go down this route. And how this escalates downward is in similar ways. So if we had 2 more states here, we can call this one light, just so you clearly understand that we ended up here by having first a light and then another light. But over here, this is a heavy attack, so this is our light heavy. Now I'm just naming them like this because for clarity, you can of course name them something else that's more descriptive depending on what you're doing. Maybe you're doing a very combo fighting heavy game, and then maybe these would have like flourishing names like, I don't know, Rising Crane or the Leaping Frog or who knows. But for clarity's sake, this explains pretty much what we're trying to achieve here. So by pressing light first and then pressing light again, we would end up here, and pressing light first and then heavy, we would end up over here. So you can see that all of the different paths will be unique, which means that we can also easily distinguish different combos with different paths in the tree. What we gain with this is also, if we go back to what we were talking about here, flexibility and maintenance. Because each of these different paths will have one animation, so we can't have any conflicts like we talked about. But you can also easily just go in and see which animation is being played and change it if you want to. So the maintenance here will be fairly easy. Another part that we talked about was that I wanted to have the ability to expand upon this. Let's say we wanted to have a medium attack as well. Well, then we could add that. We could add another state here, for example, which we could call medium. And then we could have path going down here. And equally then you could have over here, you could have a medium over here. Sorry, a state we want to have here, which we just call light medium for clarity. And then you could expand this way as well. So here you see that we have some flexibility, although we couldn't add, so we had like 5 or 4, maybe even different states here, because each of these different nodes would then all spread out into 4 new directions. Although you could have it so that not all combos are viable. For example, if you did a light attack first, maybe you're not available to do a medium attack. You can only do it after having done a light and then another light. So this is where the next medium attack appears. Let's see, like so. Light, medium, light, medium. And then maybe a light, and a light, heavy and stuff like that. So you could, you have strong control over which different paths are available and when different attacks would be available for different things. The problem, of course, with adding 3 or more like this is that these are going to be taking a lot of space, and which that means that you'll have to spread things out to be able to have enough space to allow all of that spreading. That should, however, not be a huge problem when it comes to just as few as 3, and depending on the length of your different combos. Most combos maybe aren't more than 3 or 4 attacks or something like that. But then on the other hand, you could have a fighting game where like 10 attacks or something absurd like that is essentially possible, and then this would become an issue, and then this actually becomes a weakness in this specific solution. So that's something to keep in mind on, depending on what you are after here. Another weakness that comes with this is that even though we get a lot of good things when it comes to the maintainability of this and the ease of overview and such, and also allowing us to have our different attacks and some scalability to it, what we do have as a problem with a design like this is that a normal state machine doesn't really work in a tree like this. This is currently almost, if we do this, now it's a binary tree, meaning each path allows for 2 different paths. This is not normally how state machines work in when you do animations. When we go back to our animation here, now this one is a little bit complex maybe if you haven't followed, so let's just get a bunch of these out of the way because they really don't matter. Let's just focus on this part over here. So you have an idle state and a running state or something like that, or maybe just an idle state. That would be fine as well. You essentially see here we have a very circular pathing. There's always like a way of you go somewhere and then you go back essentially, except for in this case over here we had some jump nodes, so you can't go back this way. You have to go sort of like a waterfall through in this case, but in essence they tend to flow back like this. And if we go to our combo state machine and you imagine what it would look like if we were like 4 levels down here, we would have 16 different states we could potentially end up in, and having all of them looping back to our start state would, let's call this our start state to be clear, would be very messy. So we will be working around that, and we'll get back to that later on. But that is also one of the problems that we get with this. So to handle this, we will need to add some complexity when it comes to the handling of the animation state to be able to gain the favorability of maintainability here essentially. Now maybe all of this sounds a little bit overwhelming. I'm hoping that everything of this will make more sense as we go along. For now we can just scrap this because we will be getting back to this a little bit later. And we can close this down and go to our anim graph and remove our combo state because we will be adding it later. Let's start from the start essentially. So what we're going to be doing is we're going to be approaching the development of this based on where the input will start, what will be happening from the character's point of view. So if we open up our character and we go in here, we have our event graph here, and we essentially want to have something very simple. I'm going to be adding an event for keyboard 1 and another event for keyboard 2. Actually, let's not do that. Let's actually make some proper inputs. We'll go to project settings, we'll go to input, we'll create 2 action mappings, and we'll call one a light attack, and it ended up over here. We want to remove, let's see, we don't want this one. We want to have this one, and we want to have, let's say, the 1 key. And then we can add another one, and we can say that this is going to be our heavy attack. And we want to add the 2 key for that one. That's a little bit better. So now if we go in here and we type in light attack, you can see that we have an action event for light attack, and we have one for heavy attack as well. Okay. So with these 2 different attacks, we essentially want to communicate to our animation blueprint saying, we just tried to do a light attack or a heavy attack, and we want the animation blueprint to handle whatever that means. We don't care from the character's point of view, we're just sending this information. To do this, we will be setting up some functionality to help us out. So we'll create a folder, which we will call combo, where we will have everything combo related. So we can say we want to create a blueprint interface here. We can call it BPI combo request, because that's essentially what the character is doing. It's requesting for a combo to be executed. If it is executed or not, it doesn't really matter for the character. It's all up to the animation blueprint. And what we'll say here is we want to request a combo, and then we want to send some information. To make this more legible, easier to see, read, and follow, we will be creating an enum. So we'll go here and go to blueprints and create an enumeration. We'll call it e_combo input, let's say. We open that one up like so. So obviously we will be adding our inputs into this enumerator. So we'll take add, and we can add something called light attack, and we can add another one and call it heavy attack. This also means that this is what we would be expanding if we wanted to add more attacks like medium attack or something like that. So closing that down, we can now go back to our blueprint interface and we can say we want to add an input and we want it to be of the type combo input. And new combo input as the name. This will be communicated to our animation blueprint. So we'll go to our animation blueprint and say that we want to implement this interface. So we'll add the interface over here. And then we can go to interfaces and say implement it. So here is the function or the event that will be called whenever this is called. Going back to our character, let's actually make use of this then. We want to get our animation component. We want to get our anim instance. And we want to, from that, say that we want to request a combo. Combo request message like so, and add it like there. Then we can add another one, just copy paste it over here, like so. So our light attack should be passing along a light attack, and our heavy attack should be passing along a heavy attack. So this makes it very simple from the character's point of view. It just says we got an input from the player, let's send it to the animation blueprint and let it handle it. Going to our animation blueprint again, we are now going to be handling how this function or this event is done. And how we're going to be doing this is we're going to be making use of some gameplay tags to make it a little bit easier to both keep track of, but also to hopefully understand. If you're new to gameplay tags, I have a tutorial for that. I highly recommend checking it out. But the short of it essentially is gameplay tags are sort of enumerators that you can create a hierarchy from, and you can create hierarchies so that tags are essentially enumerators with a parent-child relationship within them as well. Anyway, it should be made clear soon, hopefully. Let's go to our project settings again, and we'll go to where are we? There, gameplay tags. And let's say we want to add a tag. So we click over here and we want to add something called combo.input allowed. So this will be a concept that we will now be adding here, where we will be essentially considering there will be windows where we will be allowing an input to be received and processed. And who determines that? It will be the animation blueprint. So the animation blueprint here will keep track of if a window is open or not. For now, we'll create a variable so that can be done. We can call this combo animation tags. And we can make this of the type gameplay tag container, like so. So we can have more than one tag inside of it. So you can see here, if we add here, we could add the tags if we wanted to. We're going to be considering that this has been filled by the time we get here, even though we haven't created that code yet. So we'll be getting a reference of this tag container, and then we will be checking against if it has the tag, and we'll check against input allowed. Then we'll add a branch like so, and we'll say that if the input is allowed, then we will be accepting this input. Now, we will be keeping track of what the next input is by adding another variable. So we'll add a variable called, let's call it next combo inputs. And we'll make this of the type combo input. So this will be essentially where we store our information, and this allows us to essentially spam a key and will not actually react. We'll just save the combat input or the combo input until we are ready to play the next part in the animation, and then we'll play it, which makes for a more smooth transition and more congruent with how 2D combat games essentially are. So from here we will essentially say, actually, before we do that, let's actually do this. We want to have I think we want to add another input to the enumerator here. The reason for that is I want to have an enumerator which is not light or heavy, so that we can see that it's different. So we'll just put a slash and put it on top and save. Sometimes this can mess up if you have values saved somewhere because we changed the ordering. We want this to be the top one, and I got it here by just dragging it by adding it or holding it down here when the hand becomes apparent. If we go to our animation blueprint again and we compile here, you can see that it's set for light attack because that's what it was set for, because that's the only one that existed as the first row. But we want to set it as the slash to begin with, so this will be our sort of default state. From here we want to though set this value for the first time now. And we want to set this if input is allowed. And the value we want to set here is going to be the next combo input. Now if you want to clean it up a little bit with some reroutes, you could do that so it's a little bit more clear. But essentially, if the window is allowing us to take input, then we take the input, otherwise we do not. So we're essentially doing nothing with this false for now. So that's all we need for now. We can compile and save and leave it like so. So now let's actually create our animations that we will be using as our attacks. In this project that we have here currently, we have in place these sprites available here. It's a 26 sprite animation, which essentially looks like, I believe this one has the whole animation. So here you can see this essentially is 3 different slashes in one attack, and you can use whatever sprites you want here. It doesn't really matter for the tutorial here. But what I'm going to be doing here is, since I have an attack or a flip book that is 3 different slashes, I'm going to essentially create 3 attacks from this. So what I can do is I can go here and see that, okay, we start from 0, we go up here and maybe at sprite 7 we start the next attacks, or we say sprites 0 to 7 is gonna be the first attack, sprite 8 to, let's say 13 is gonna be second attack, and the remainder is gonna be the third attack essentially. So let's do that. So we'll go to our sprites, we'll go 0 to 7, right click, create flipbook, call this attack 1, and we go from 8 to, I believe it was 13, and we create a flipbook and we say attack 2, and then we go from 14 to the end and we say attack 3. So now we have our 3 different flipbooks, which corresponds to the 3 different attacks. We now need to add this to the animation source. So we'll go to our animation source. We'll create 3 animation sequences for this. We'll call them correspondingly. So we'll call it attack 1, which will be using attack 1 flipbook. We add another one. We'll call this one attack 2. We'll use the attack 2 flipbook for that one. And we add a third one, which we call attack 3, which we use the third flipbook for. So now all of that is done and we have our animation sources set up. Sorry, our animation sequences in our animation source set up. We'll make sure to save so everything is safe in case something goes wrong. So now we have these different attacks. Let's start making use of them. We can close down our animation source, our light attack, our combo input, our BPI, our project settings, and then go to our animation blueprint. In our animation blueprint, let's go to our anime graph. We will now be creating another state machine, which we will be using in tandem with the normal one. Doesn't matter really what we have in this one for now, and doesn't really matter what it's called either. What we will be doing for now is we will be adding a new combo state, a new state machine. So we'll type in state machine, and this one we will name combo state machine to keep it simple and easy. For now we can also disconnect this one and hook it up like so. We could also hook it up here if we wanted to. Going in here, we're now going to be creating our states for our combos. So for me, I'm going to be adding a start state. So we add an animation state here. We'll call this the start state. The point of the start state is essentially just to work as a branching node for us to begin from and to be able to circle back to at the end of combos. From this, we will, because of simplicity of understanding, we will be creating two more states, one to the left, one to the right. The left one we'll call light. We can even call it light start to make it clear that this is where the light combos start. And here we can have heavy start. So that's where the heavy combos start. So the start state can go to either of these depending on the inputs. So that's what they will do. If we go into the transition over here now, we can see that what is needed to transition over to this state. We're going to be taking our next combo input and we're going to compare it. We're going to be saying if it is equal to the enum of the light attack, then we're going to allow a transition. So if we go back, that allows us to go from the start state, which doesn't have an animation in it, we're going to be leaving it blank. It allows to go to the light start. So we have nothing essentially keeping it here. We will just be immediately entering this state machine, which will allow us to come in here, and then we will only go in here if we actually have a combo input processed, which means we will either immediately go here if we have light or here if we have heavy. So we'll go here and make sure that this one is compared against heavy for this branch, like so. So now this already allows us to transition to the two first states. For the first one, I'm just going to be adding an animation. So we're going to be adding play attack 1. This will represent my first light attack. Doesn't really matter which one it is, just that they are somewhat different so you can see the differences. We want to have it not looping because these are once and done sort of animations. And in the heavy start, we are going to be doing the play attack 3, let's say. Again, if you have other animations, make sure to use others so you can see the differences between them essentially. So now we have the attack 1 and attack 3, which are going to be happening if we're pressing these buttons. Now, to have us transition to this state machine, we will be actually making use of, here we go, anim graph. We will actually be making use of some logic to make sure that we are entering the proper state machine. So we'll consider our normal state machine as our default and our combo state machine as something that we only transition into when we're doing combos. To do this, we will make use of a select, like so, and we'll do it by a bool. That will make it fine for now. And essentially what we wanted to do is we wanted to have the result come out like so, depending on some kind of circumstance. In this case, we are going to be making use of our animation tags here, and we're just going to be saying if we have a tag of the type combo, then we go into the combo state machine. So we need to change this position between these two, like so. So if we have any combo tag, then we are essentially doing something inside of the combo state machine. So that's when we transition in here. And if we do not have one of those tags, we should transition into this state machine and do the normal stuff. Since we are using gameplay tags, this makes for easy logic because we will be adding a few more of these different combo subsequent children tasks tags. But by choosing just the hierarchical parent, the combo one, and saying that we don't have an exact match, we can have any of the underlying combo tags here, so input or any of the other ones that we add later, and as long as one of them exists, then this will be true and we will be considered to be inside of the combo state machine. So to build upon this, we can already add another combo state, because we have this situation when we are currently in the locomotion state machine, which is called a new state machine in here. If we, like so, if we play, we will have just the normal locomotion going around like so. But we have the situation where we get an input from the player, from this, a request of a combo, then we immediately need to identify that we should be starting a combo. So we'll add another tag. So we go to project settings, we go to gameplay tags, and we'll click on combo, and we can go here and click the plus, which means add a subtag. It will fill in all the hierarchical tags above, which is just combo in this case, and the dot, and we'll add start. So we have now another combo tag, which is called start. We close this down, we go to our animation blueprint, and we go to request combo, and we can from here now expand a little bit on this logic. We want to say the following. If we come in here, we can add a branch, because we're going to be making another comparison first. And we're going to be saying, if we have the tag, and again, just combo, so any of the tags, then we're going to be doing something or else not. So in this case, if we already have a combo tag, then we're already doing combo things, so to speak, and we'll go over here to the next comparison to see if input is allowed, and then process the input. If we, however, come here and we get the information that we do not have a combo or proximity tag related to combo, then we go into the false. But since we have come here because we have requested a combo input, then we will actually be adding a tag, which is the one that we just added, which is called start. So we'll say we'll add a tag of start, which means that we're actually now starting the combo. From this then, from the continuation of the adding of the tag, we still want to process the next combo input. So we'll hook that up over here, where the combo input is being done. And then we're done here. So what will happen now is the player presses a key, requests a combo like light, and it's just in its normal state machine. We get it in here, we see that we currently do not have any tags for combo. We'll say add the combo start, which will then go to our anim graph, and we'll identify over here that we have started our combo. And that will transition us into the combo state machine. We then add our next combo input into our variable here, which allows us to, in our combo state machine, then transition either to a light start or a heavy start. And that's how the combo begins. Now, as a cost to having this easily overviewed view of all the different combos that we have, we do need to have some sort of complexity in the form of code to maintain the different pieces of information that we either process or condition with substates inside of this. Let me explain. When we transition between these different states, we need to update with certain amounts of information. Like, for example, when we go into our start state here, we have entered it by having the start tag added, but we are going to now immediately transition to one of these states because we have an input already. Now, we're going to be making use of the callbacks that we have available here. We have one on the enter and on the leave of the state. We are going to be creating one on the leave state here. We're going to be saying that combat sequence begins or something like that. Then we copy the name. This means that we now can add a custom event in our event graph, which we can hook up some code to. Let's see where it makes sense. Over here maybe. So we add the custom events, like so, and paste in our name. So from here, we're now going to be handling essentially the situation of when we leave that first state. And when we leave that first state, what we need to do is we had a tag which was called start. We don't need that anymore because we have already started. And at this point, we have also determined that we have now started doing the combo, so we want to actually allow input. So we'll take our combo animation tags here and we'll add a tag. And the tag that we want to add is the input allowed. After that, we'll take the combo animation tags and clean up the tag we no longer need, which is the tag that's no longer representing of what we're currently doing. So we'll remove the start tag. So now we have cleaned up essentially the transition of, sorry, wrong state, there we go, from here and moving on to here. So also now while we're here, I think I didn't, yeah, we removed the loop animation on this as well. None of the animations in the combo should be looping because they're all like one and done essentially. So let's say we have a heavy transition now and we go into the heavy here. Now this is what's called a leaf when it comes to a tree. A leaf is a state in which there are no subsequent children paths to go to. So this will be like the last part in a combo sequence essentially. If this was the combo sequence, then just had this one. This is the end of it. And for that, we're going to be making use of the states or the callbacks for this state as well. So we're going to be saying here, in the case we have a leaf, we're going to be adding a function for that. We're going to be calling it last combo state entered. I think that is very descriptive, like so. And press enter. And on that note, we're going to be taking that name and we're going to be going back to our event graph and we're going to be adding a custom event and using that name like so. Now what this event is going to be doing is essentially put us in a proper position where we have essentially entered a place where we cannot add any more input, so the combo can't continue. So we need to prepare for that, which means that we need to tell our combo animation tags here to remove the tag that allows for input. So we're no longer going to be allowing input. But in addition to that, we also want to clean up some other information. And to do that, I'm actually going to be adding another custom event. And we're going to be calling it consume combo input. And this will essentially be saying that once an input has been, we're entering a state which we got to because of a combo input, we're going to be cleaning it up. So we're going to be saying our next combo input, which had, sorry, not get, we're going to be getting a set. So if this one was heavy, which made us come in here, we're now going to be setting it to the slash, which is our default, saying we don't have a next combo input. In addition to that, we are also going to be informing our combo animation tags that we're currently playing an animation, so that we have a state for that. Because in PaperZDS, at the time of this recording at least, you can't make use of montages, which I have used in my other combo tutorials. If you're interested, I have tutorials for that as well. Which is why we have this a little bit more complex handling of this. And to have something similar to a montage playing, we're going to be using a tag for it. So we're going to go to our project settings again, and our gameplay tags, adding to our combo, and saying playing montage, like so. So now we have our playing montage as well here. So we'll close it down, we'll go back to our animation blueprint, and we're going to be saying we add a tag that a montage is playing. So we're playing some sort of animation currently, and then we're consuming our input by setting it back to default. And this is what we want to do here as well. So consume combo input. So once we have added that tag that we're playing something, remove the actual variable that we had, we want to remove that input is no longer allowed. So we can no longer get another input because we are in the last leaf of the tree essentially. So there we go. Now we have part of this. Now we have entered like the final stretch for what a combo is essentially. What we will do from here is we'll go to our event graph and we'll go down here somewhere. And now we're going to be making use of one of the event dispatchers that is available through PaperZDS already, which we can find if we go to functions overrideable over here. We can get on anim sequence playback complete. This event happens whenever a animation sequence is played and it finishes essentially. Now this is a generic one, so this one will be called everywhere in your animation blueprint whenever an animation sequence is played. So it's important that we need to narrow down when we want our current code to run for this. So we want to add a branch immediately to make sure that this is combo related code that we're going to be running. What we're going to be doing is essentially we're going to be doing two things. First, we're going to be taking the combo animation tags and we're going to be checking has tag. If it has the tag, and we're going to be checking the combo parent, making sure that if we're in any kind of situation where we're in the combo state, and we want to check against that. But we also want to do something else here to make this work doubly for us. We're going to take our next combo input and we're going to compare it against no next input. Essentially that we're saying that we have no next input assigned already, which means we'll get back to this later, but essentially this is what we're going to be adding, and we're going to be having an and boolean. So both of these need to be true for us to continue and doing our code here. What we're going to be doing here is essentially we're going to be calling the end of our combo. And how we're doing that is we're going to be let's go up here to the start, combat sequence begins, and create a custom event. So, and we can call this one combo finished or something like that. Yeah, that'll be good. Okay. So what we will be doing here is we're essentially just going to be resetting the situation so that we are no longer in a combo state at this point. So we will be removing all of our different tags that are of relevance for us. To make this more compact, we're going to be creating a function. We can call this clear combo tags. We'll get the combo animation container and we'll say remove tag. And we're going to be removing the tag in case we have it that allows for, sorry, not input allowed, but playing montage, like so. In addition to that, we are also wanting to remove, actually we are wanting to remove that one as well, so let's do that. So we remove the input allowed as well. These should be all the tags that we can have, so from here we can just return. Like so. Then we go back to where we were and we're just going to be calling this function over here. Now we do have an edge case here where this could be called multiple times when an animation reaches playback complete and doesn't actually transition anywhere else, which means that we can get this call multiple times. So we're going to be putting some defensive coding in here to prevent that. So we're going to be adding a do once node here. And we're going to be saying we're allowed to do this once, and the reset will happen whenever we start the combat sequence. So we'll just hook that up like so. That allows our combat sequence to be the start, which allows our combat finish to actually happen itself. Once everything is done here and cleaned up, we essentially want to reset the whole combo. We're going to be doing that by jumping to a jump node. We compile, we go to our state machine here, and we're going to be adding a jump node here, and we can call this one combo reset is a good name, I think. And we can save the name, and then we hook it up to our start sequence here. So the point is that when this is called, we're going to be jumping back here, and the combo should be reset essentially. So after we have cleared our tags, we'll call jump node, and the jump name is the one that we copied. And now we need to enter the state machine name as well, because we have multiple state machines. So we'll add that one over here. So we'll copy that, go back again, and add it there. So now we can jump to that node here, theoretically. Yeah, so with all of this in place, we should have this, what did I call it? Combo finished? Combo finished, I think. Yeah, like so. So in case we are having a combo tag and the next input is blank, so that means that either we have reached the end of a leaf node. Let me demonstrate. Either we get here, then we clear out the input from this event, and then we don't allow any more input, so we will end this by having it empty. Or if we have another combo somewhere where it's much longer, but you don't finish it entirely to the end, but you just don't put a new input, that will also cause this event to happen, and you'll have no input, but you're still in a combo, and that will mean that it aborts as well. So we compile and save. So now we have gotten pretty far, and hopefully you've been able to follow everything so far. Let's actually give it a try and see if this works. So if we play now, there we go, and we press the 2 key, which is the heavy attack. It attacks and it returns back into its idle state again. If we were to use the light one, we'll get a freeze because we haven't set up the light attack like we have the heavy attack when it comes to the animation blueprint. And it's state machine here, because we have the transition here to the last combo entered for the heavy, but not for the light. But for the light now, we're going to be making it a little bit more advanced. We're going to be adding some more layers to it. So we're going to be adding 2 states here. So add the animation state here, an animation state here. We'll call the left one light, just so it's super clear that this is what happens when you go light and then light. And this one we'll call light and heavy, so that we understand that light attack followed by a heavy attack is where it leads us over here, like so. So these are the 2 transitions, and we're going to be adding a animation here. So we're going to be adding a play attack 2 for the light attack, so it looks different from the first light attack. That's the whole point here. Only we remove the looping because we don't want it to be looping again. We go to the heavy attack, and we're going to be playing attack 3, just like the normal that we have for the heavy attack when we start the heavy combat chain. Doesn't really matter, it just makes it easier to visibly see that it's happening. This one shouldn't be looping either, like so. Now the transitions to these are going to be very similar to what we had before. Before we were just checking the next combo input to make sure we had one. So we'll go to the one that says light, and we'll say next combo input should equal, and then light attack. But that's not all, because we already have a previous animation which we need to finish as well. So we can right click and type in remaining, and we'll get the time here that remains, and we'll just say that this also needs to be equal to 0 for this to be okay. So an AND boolean for this, saying that both the animation needs to have fully played, and we actually have a next input to transition is required for us to transition to this. So if we just take, yeah, it'll be fine. We'll copy it, go here, click in sorry, not here, we want to be in the transition, paste. We remove the attack 1 here because it's not accurate. In this case we're playing a different, actually we are playing exactly the same one, sorry. We can take a remaining attack like so, comparing against 0, and this time we want to have a heavy attack over here, then we will transition here. Okay, so this means that the transitions are okay. Now, we have not set up the light attack here like we set up the heavy. And the reason for this is we need to have slightly different logic between leaves and normal transition paths. Leaves need to have the on state that says that we have entered as a leaf essentially, which means that the combo no longer takes input. But for a state like this, which has transitions, we need to have some other functions or other code running when we enter and when we leave it. So, starting off, when we enter a light start, if we go back to our event graph, we want to do this function that we did before, consume combo input, because that's exactly what we're doing. We're starting a combo playing montage, and we're resetting the combo input for the next input essentially. So this is the name that we're going to be taking and placing as our enter case here. When it comes to the exit state, it's a little bit different. Now the remainder of these states that we have here are both leaf nodes, as you can see. So what we need to do is we need to copy this enter function for both of these. And that's essentially it. So these are how they will be looking. The leaf nodes will all have the enter state event name over here. Normal states which have leaf nodes under them will have the consume combat input. And actually, I think to make things a little bit more clear, our consume input over here, consume this one, if we do it like this, let's just hook it past like so, and this one will cut out to paste instead over here. It might not be as clear otherwise, I think. So essentially this play montage tag that we have is only meant to exist on on a leaf node essentially. And that is because it needs to exist there as a tag because we have removed our input allowed tag, which means we might not have a combo tag available otherwise, and we need to have one that lasts as long as the animation does. So that's what this exists for, and that's why it's better to put it on. So we add it to our last combo state entered, and then it will be removed if we have one on our clear combo tags when we enter the combo finished, which we'll reach if we get to the playback complete essentially here. So that's how that works. Okay, it has been a long road, but let's see what we actually have now. If we go and press play, we have our character. I press light attack. You can see it does the light attack and then transitions back into idle. Again, since this is using sprites, we don't have blending like we have with normal 3D models. So it's probably best if you have some animations that seem to fit fairly well with both the idling and the next animation that's supposed to be used, but that's up to you. Since it's sprite, it's happening so fast. Usually it looks fine regardless. But anyway, pressing light, we do our light attack and transition back. Pressing light and then pressing light while we're doing the attack will allow us to do the first two light attacks. If we press light and heavy, we do those attacks. If we just do heavy, we do heavy. And it all transitions back to where it was before as well. So that is the actual combo animation part done. However, there is something else we might want to take into consideration, and I'll show it like this. Since we're doing combos, and in games like this, you should be taking into consideration that you might get interrupted. We want to take that into consideration as well. So what we'll do is we'll put in some code in our character, which will simulate us being interrupted. So I'll type in keyboard 4. And from here, we're supposed to do something that simulates, let's say we're getting injured by an enemy or something. So it's supposed to play some animation and then transition back into idle or something. So this will be that sort of event. In our animation blueprint, if we go back to it, now this one will look differently depending on if you have followed this before or if you're just having your own. But in your locomotion state machine, what we want to do here is essentially we want to create a jump node here, which we will be calling, let's call it damaged. And this one will then go into a state. And this will be our damaged state. And it will transition to this place. And in this case, I'll just use a placeholder animation here. It doesn't really matter which one I use. So play, do I have a jump? I have a jump. I think it's a fairly long animation, but that will be fine. And we'll play it once. And we'll make sure that the transition here is going to be when time remaining for the jump, essentially when we have finished being injured, is equal to 0. Then we'll transition. Which means that we'll get damaged, play the damaged state. When we transition, we go back into idle. Now, if this happens here, that's fine. But if it happens in the combo state, we need to make some considerations. To make this a bit cleaner, what we're going to be doing is we're going to be creating a blueprint interface. We're going to be calling it BPI state requests. And we're going to be taking a state, call it jump state request even, to be clear. We'll have 2 inputs. Both of them will be of the type name. The first one will be called something like jump node. And the second one will be called state machine name. This is because this is supposed to mirror the jump node itself. If we go to our character here and we went and said get our animation component, get anim instance. From this we could type out just jump to node, and you'd have the jump and state machine here. But we wanted to use our requests jump instead. And the reason for this is that if we do it like this, we can actually add some logic to it. For example, we called our jump node damaged, I believe. Let's make sure that we get it right. So we copy this name. That's the name of the actual jump node. There we go. And the state machine here in this case is very poorly named because I just have it called new state machine, but yours might be better. Like so. And then we need to go to our animation blueprint and say that we actually implement this interface. So BPI state requests, like so. We implement this interface over here. And now we need to add this extra logic. So what is it that we need to do? Well, we need to do a few things. First of all, we need to clear our combo tags because we want to say that we're no longer in the combo state, because that's what drives us to be in that state machine. After that, we want to jump to node, and we want to use the jump node name and jump node state machine name, like so. The problem with this is, however, this will happen too quickly. We can't have it be done like this. What we need to do is we need to allow it to clear the combo tags and give it one frame so that it can transition to the right state machine, and then it allows this jump node to happen properly, because otherwise this will not happen fast enough. So we'll do a delay node, and we'll have a duration of 0, which means it will just skip one frame, and that should allow us to transition. So now if I press by 4 key, we should be requesting to change state even if we're in the middle of something. So let's see us. If I just press 4, we can see I do a jump animation. If I press 1 and then quickly, which is the light attack, and then quickly press 4, you can see that I transition over to that state. So that's something that I feel like would be worth taking into consideration, because now it allows us to... We now have the possibility here of both having our logic contained within its own state machine, which means that we have reduced the complexity and can keep everything related to it here. We have the ability to transition between our combo states from another state, which is our normal locomotion, and also back again, depending on if we're getting damaged or interrupted in any case, which is what this is supposed to be symbolizing and demonstrating essentially. So you get a damaged attack, it would call something like this, and it would handle whatever logic that you needed to transition properly. And of course, if you expand upon this and you add more tags or whatever like that, you of course have to take into consideration that as well. But essentially, we have managed to create a combo system that is easy to expand upon. We can add new states. We can just, if I wanted another state here, I could call it, to make it clear that what it's doing, it's light, light, light. But since this is now a leaf node, this one needs to have this function as it enters, and this is no longer a leaf node, so it needs to have the consume input here instead for it to function. And then you would have to add the transition, of course, just like you did here, and then add an animation here and everything like that. So it's very simple to add to it. And in addition to that, you also have the possibility of doing something like, if we want to have a heavy attack here that goes into a branch over here somewhere, it's perfectly possible to do so. So that if we go heavy and then light, and we're supposed to end up in playing this animation over here, we can just hook it together like this, and we can create really complex transitions between the different animations using this. And all we need is the little bit of logic in the background, making sure that we have some states properly set up for our event graph here when it comes to our tags and our next combo input and such. Anyway, that is all for now. I hope that this was helpful. Keep on learning. Take care. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.